welcome to Toydell online class. So we want to discuss about logarithms and logarithmic equations. Of course, I want to assume that we have been introduced to logarithm at the upper grade, like grade 10, 11, or 12. That is the secondary level. So we know how to check for logarithm of number less than 1 and logarithm of number greater than 1. So I'll be introducing logarithm. So what is logarithm? The logarithm to a base of a number is the index to which the base must be raised to be equal to that number. For instance, the log number, let's say number p, the logarithm to base of a number p is the index x to which a must be raised to be equal to p. That is, if we have p is equal to ax, then the log a to base log p to base a is equal to x. That is what we are talking about. So the logarithm of a number, the logarithm to base a of a number p, the logarithm to base a of a number p is the index x to which a must be raised to be equal to p. And this is what we are going to have. And of course, we can write this also in the index form. That is, when p is equal to a raised by x is the index form. This is the index form. While log p base a is equal to x is the logarithmic form. So there is this relationship between logarithm and logarithmic form and index form. So if you have index form p, which is equal to a raised by x, then when we take the log of p base a, that must give us x. And that is what we have from the definition of logarithm. So since we know what logarithm is all about and how to represent it in index form, I can go ahead and introduce the laws of logarithm. The laws of logarithms. So just like under indices, we have the laws of indices. So the first law of logarithm says that if you have log p multiplied by q base a, this is equal to log p base a plus log q base a. Let's look at this critically. When we have the log p times q base a, the law says that when you have products, you can split it as log p plus log q. So that is the first law of logarithm. Then the second law says that when we have log p divided by q base a, the first law is talking about multiplication of the logarithm, so that by the time you split it, it becomes addition. And this second law, where we have division, log p all over q, the law says that you can have it to be log p law. Then the third law says that when you have log power n base a, log p raised power n base a, the law says that this n this can be written as n log p base a. That is, when we have log p raised to power n, the n can come down so that it will be n multiplied by log p base a. Then the fourth law says that if you have log a base a, if the log and the base is the same, then it's equal to 1. Please let's take note of that fourth law. That is, when the log a and the base, the log and the base are equal, then we are going to get 1. Then the fifth law says that when you have log 1, the fifth law says that when we have log 1 base a is equal to 0. So log 1 is equal to 0. Then if you have log b base a, this can be rewritten as the reciprocal 1 all over log a base b. That is, if you want to interchange the log and the base, just write it in form of reciprocal. If you have log b base a and you want to change the log to log a base b, just write it in form of like as you have it as reciprocal of what you are given. Then the last law that we are going to talk about says that if you have a raised to power log b base a is same thing as b. So this is the last law that we are going to talk about. Now I want us to note something. Of course, we usually talk about types of logarithm. So logarithm to base 10, they are referred to as common logarithm. That is, we have logarithm to base 10 and to base e. If you have logarithm of a number to base 10, they are called common logarithm. So they are called common logarithm. If you have, and most often time, let's say we have log a. If you are given the log of a number and the base is not given, you assume it to be base 10. Most often time, when we have log to base 10, we don't normally write it there. So if you are given any question, let's say log 8, without the base, you assume the base to be base 10. And that has been the standard. Logarithm to base 10 of a number is called the common logarithm. That is the first one that we have. Then there's this other one that we call the natural logarithm. When we have the logarithm to base e, when we have the logarithm of a number, let's say x to base e, then this one is called the natural logarithm. It's called the natural logarithm. So where e, of course, we know the value of e in our calculator, scientific calculator, to be 2.7182 ... So this first one, as I've said earlier on, when you have a log of a number without base, the base is assumed to be base 10. And that is what we refer to as common logarithm. At least at the elementary, that is what we normally have. But if you have a logarithm and the base is exponential, that is log e, it is referred to as natural logarithm. And that value of e, if you check your scientific calculator, you have something like this. This same thing as nx. So when you check your scientific calculator, you have this symbol there. It's talking about the natural logarithm. In this case now, the base is exponential. The base is e. So let's take note. When we have a logarithm without base, you assume the base to be base 10. Then when we have a log to base e, which is otherwise known as, if the log is log x, then we call it nx. It's talking about natural logarithm. So I want to take examples under logarithm. Let's take examples. Let's say example 1. You can be asked to simplify. Let's say we are asked to simplify the following. We are asked to simplify the following. The first one, where you have log 27 base 3 plus 2 log 9 base 3 minus log 54 base 3. So let me just take the example one after the other. Now let's look at this first example. You know, I said something that under natural logarithm, under common logarithm, if you are not given the base, assume the base to be base 10. But in this case now, we are given the base to be base 3. So there won't be any assumption since we are given the base. So it's still common logarithm. So in this case, what do we do? What do we do? We have to apply the law, some of the laws of logarithm to be able to simplify this expression. Now let's go. The solution. Here, what do we have? We have log 27 base 3 plus, if you look at the third law says that these two that we have here can become 9 raised to power 2. If you check this, the third law, log, this will now be log 9 raised to power 2 base 3 minus log 54 base 3. And of course, when we have addition, when we have multiplication, there is equal to addition. Then when we have division, is equal to, when we have subtraction, is equal to division. That is, if I want to do this now, this will give me log 27 base 3 plus log 9 squared is 9 times 1, 81 base 3 minus log 54 base 3. So if I'm to apply that law now, I will say this is log 3. When I have addition, I multiply. When I have subtraction, I divide. That will now be 27 multiplied by 81 divided by 54. Of course, what do we have here now? 27 here 1, 27 here 2. Then I can rewrite this. From there, I can rewrite this as log 81 divided by 2 base 3. So what I have here now, I can write it as log 81 base 3. Division will be minus log 2 base 3. So 81, I can write 81 as index of 3, so that I'll change this to log 81 is 3 raised power 4 base 3 minus log 2 base 3. There's nothing I can do there. Then this 4 can come down based on the law of logarithm. But I will have 4 log 3 base 3 minus log 2 base 3. So in one of the law, I think the fourth or fifth law, it says that if the log and the base are equal, is equal to 1. So I'm going to get 4 times 1 minus log 2 base 3. So 4 times 1 is 4 minus log 2 base 3. And that will be the final answer. So that will be the final answer. Just try and just go through the laws of indices, the laws of logarithm. You see, let's learn that law by heart. I'm not saying you should cram, but when you go over it, repetition enhances learning. When you go over something when you go over something over and over again, then you will be able to memorize it. So this is what we get. So let's take another example, probably example 2. Let's call it example 2, where we have simplify. Let's take another example, log 3 base 9 plus log 243 base 9 minus 2 log 3 base 9. So in this case now, we are given the base to be 9. So we can't make any assumption. It is when we are not given the base that we assume it to be base 10. So here we have log 9 base 3, log 3 base 9 plus log 243 base 9 minus log. In this case now, these two can come up to be 3 squared base 9. Then if we move from there, what do we have? We now have log 3. When we have addition, you multiply times 243. Then when we have division, minus subtraction, we divide. That will be 3 times 3. 3 squared is 3 times 3. So 3 here, 3 can take care of this. 3 here, 1. 3 here is 81. So we are going to get log 81 base 9, which is same thing as log. I can express 81 as index as 9 raised power 2. That will be 9 raised power 2 base 9. From here now, the 2 can come down from the third law. This can be equal to, from here now, we can get this 2 log 9 base 9. And of course, if the log and the base are equal, that is 1. That will be 2 times 1. Then at the end of the day, we have 2 as our answer. So that's what we're going to get. So then I want us to note something. Let's note something. There's what we call change of base. That is, we can change the base of any logarithm. So let's briefly talk about change of base. Change of base in logarithm. Before we give further example, then before we introduce logarithmic equations. Change of base. If we let log p base b to be x, if we let this equal to this, then this is the meaning p is equal to b raised power x. If you are given log p base x, log p base b is equal to x. If you want to rewrite this now in index form, this p will now be this your base raised to the power of x, and that's from the definition of logarithm that I gave. That is what we are going to get. So that is what we are going to have. So now, log p base b is equal to x. That is, we have log p base b equal to x. Now we know that this p is same thing as b raised to power x. So if I change this now to log, let me say this is, let me now say I have log p base c. What is my p? P is equal to b raised to power x, then base c. If that is what I have, then this x can come down according to the third law, x log b base c. Then what is the implication of what I have? That is I have that x log b base c is equal to log p base c. That is, this is equal to this. If I make x the subject of formula, look at, If I make x the subject of formula, what do? I will divide both sides by log b base c. That is, x will now be equal to log b base log p. It will be log p base c all over log b base c. That's what we get. Therefore, what is x from the onset? From the onset, we know that x is equal to log p base c, which is now given as, let me write this. We know that x is equal to log p base b, which is now given as what we have on the board, log p base c all over log b base c. Look at, we have been able to change the base of this log from b to c. But what is the implication? If you are given the log and the base, you can rewrite it as saying, instead of saying log p base b, you can change it to log p all over the log of that base. And that is what we call change of base. So please note, if you are given any question, we should be able to change the base. If you are to change the base of a logarithm, for instance, when we have log p base b, if you want to change the base of this now, it will be log p divided by log b. It will be log p divided by log b. Then I'm going to give example on this, on where to apply change of base. Let's say example 3. Example 3, where we have show that log b base a multiplied by log a base b is equal to 1. That is what we are asked to show. So how do we show this? Solution. What are we given? We are given log b base a multiplying log a base b. Then what can we do here? I can change. With the knowledge of change of base, I can rewrite this. What will I do? If I want to change this now from base a to another base, I will just say log b divided by log a, multiply by, the same thing goes, log a divided by log b. So this can take care of this. This can take care of this. At the end of the day, it's equal to 1. And that is what we are required to prove. We are required to prove that log b base a times log a base b is equal to 1. And that is what we have done successfully. Then I'm going to take the last example under logarithm. So I'll take the last example under logarithm. Then I'm going to introduce logarithmic equations. The last example, let's say example 4 under logarithm. In this case now, we are given that log 2 is equal to 0.3010. As I've said earlier on, that if you are given the log without base, you assume the base to be base 10. So in this case now, you should know that if you are given log 2 without base, the base here is base 10. So please, let's take note. And we are given log 3 to be equal to 0.4771. And we are given log 5 to be equal to 0.6990. Then the question now says, find the first question. We have to find log 35 base 10 minus log 17.5 base 10. Then the second question, we are to find log half base 10. Then the third question. So we only take 3. We only take 3 questions here. After this, we can call it a day. Then we go to the logarithmic equation. Log 64 plus log 27. So now let's solve this. We have 3 questions here. We are given the value of log 2 to be 0.301. We are given the value of log 3 to be 0.4771. And we are given the value of log 5 to be 0.6990. So we are required to find this. We start from the first one. We are given log 35. Of course, log 35 is not compulsory to put the base. I said when you are not given the base, you assume it will be base 10. So let me just remove that. Log 35 minus log 17.5. If you look at the law of indices, when you have subtraction, it is division. When you have addition, that's multiplication. So if you apply the second law here, I can change this to log 35 divided by 17.5. And of course, 35 divided by 17.5 is log 2. That will give us 2. Then if this is 2, what is log 2? Log 2 is given as 0.301. So our final answer will be 0.3010. So we have been able to solve the first question. We have been able to solve the first question. We can go to the second one. The second question, where we are given log half. Log half. So, of course, we can split this as log 1 minus log 2. And of course, log 1, that simply means log 1 base 10, log 2 base 10. So what is log 1? From the loss of logarithm, log 1 is equal to 0 minus, what is log 2? Log 2 is given as 0.3010. So 0 minus 0.3010 gives minus 0.3010. And that is the answer. So I'll go ahead and solve the third one, C. So I will solve this third one. The third one, we are given log 27 plus log 64 plus log 27. So this is what we are given. Look at this 64. Can I write this 64 as index of another digit? Let's say 2. Yes. Can I rewrite 27 as index of another another digit? Yes. So I want to change this 64 now. I will change this 64, log 64 to, 64 is 8 times 8. Then 8 is 2 raised power 3. So I can change 64 to 2 raised power 6 plus log. I can change 27 to 3 raised power 3. Then from there, the third law, this 6 and this 3 can come down. So that I will have 6 log 2 plus 3 log 3. And that's what we are going to get. So this will be 6 multiplied by 0.3010. That is the value of log 2. Then this is 3 into bracket is 0.4771. So if I multiply 6 by 0.3010, I'm going to get 1.8060 plus 3 multiplied by 0.4771. I will get 1.4313. So if I add the two together, I'm going to get 3.2373. And that will be the final answer. So that will be the final answer that we get. So since we now have basic knowledge about logarithm, I can go ahead and introduce logarithmic equations. Logarithmic equations. So the second subtopic is logarithmic equations. Of course, from the word equations, you should know that we are going to solve some problems involving logarithm. So I will give about 3 examples and we'll stop the class. So let's see examples. Let's example 1 under logarithmic equations. Solve the following. Or let me introduce the example one after the other. Solve log 2 into bracket x squared minus 2x plus 5 is equal to 2. Okay? So this is what we are required to solve. So this is an equation involving logarithm, and it's called logarithmic equations. So how do we solve this? Where we have log x squared minus 2x plus 5 base 2 is equal to 2. Of course, when you recall that when I introduced this concept, I know that log p, where I said log p is equal to b raised by x. So in this case now, I know that x squared minus 2x plus 5, it will be equal to 2, this 2 raised to power 2. Then x squared minus 2x plus 5 will be equal to 9. It will be equal to 4. I can bring in 4 to get x squared minus 2x plus 5 minus 4 equal to 0. So if I rewrite that, I'm going to get x squared minus 2x plus 1 equal to 0. Can I simplify this? Can I simplify the quadratic equation on the board? Yes. So I can factorize this. So this will now be equal to x squared minus x minus x plus 1 equal to 0. So I do the grouping. I have x here, so I will have x minus 1. I have minus 1 here, so I have x minus 1 equal to 0. So I have x minus 1 equals 0 or x minus 1 equals 0. So x is equal to 1 or x is equal to 1. Then from what I have on the board, the two roots of this equation is x is equal to 1 twice. Since there is repetition, this is how we write it. S is equal to 1 twice. So this is how to solve equation involving logarithm that we refer to as logarithmic equations. So we can take another example. Let's take another example in order to buttress the point. So let's solve, let me clean this. I will take another example. Then after this, we take one more. Solve log, in this case is 10. X squared plus 6x plus 28 is equal to 2. Look at, even if you are given this second example now, under logarithmic equations, even if you are given this without base, just put 10 there, because we have been able to establish that if you are given a if you are under common logarithm, if you are given a logarithm without base, the base should be assumed to be base 10. So let's say you come across some textbooks and you are not given the base, just go ahead and assume the base to be 10, and you are on the safer side, because that has been the standard. So from this example to now, how do I solve this? This value here will now be 10 raised power 2. That is, I'm going to get x squared plus 6x plus 28 will be equal to 10 raised power 2. Then x squared plus 6x plus 28 will be equal to 10 raised power 2 is 100. So I can bring in 100 to the left-hand side. I will have x squared plus 6x plus 28 minus 100 equal to 0. Then this will be x squared plus 6x. That will be minus 72 equal to 0. And this at this stage, we have gotten a quadratic equation. Then this quadratic equation is factorizable. We can factorize it, of course. The minus 72. What are the two factors of minus 72 that will give us plus 6? That will be 12 or minus 6. So I will express this as x squared plus 12x minus 6x minus 72 equal to 0. So I'll do the grouping. X is common, I bring out x. I'm going to have x plus 12. The minus is common here, I bring it out. I'm going to have x plus 12 equals 0. Then, since what I have in the two brackets are the same, so I will only pick that once. I will have x plus 12 equals 0, or I will now group these two. X minus 6 equals 0. So x is equal to minus 12 or x is equal to 6. Therefore, x is equal to minus 12 or 6. And that will be the value. That will be the value of x. So x is equal to minus 12 or 6. So that will be the value of x. Then I'm going to take the last example under logarithmic equations. Let me take the last example under logarithmic equations. The last example. Just note that if you understand all the laws of logarithm, you learn those laws by heart, and you are able to record those laws, you should be able to solve any given problem under logarithm and logarithmic equations. So try and learn the laws of logarithm by heart. So let's take the last example, and that will be the final example under logarithmic equation. You are given solve log x plus 9, x plus 9 base 10. Even if you are not given the base, you know that it is base 10 plus is equal to 1 plus log x plus 1 base 10 minus log x minus 2 base 10. This is what I'm saying. Even if you are not given the base, let me just clean the base. If you are not given the base, you assume the base to be 10, because that has been the standard, that if you have a logarithm, common logarithm, not a natural logarithm, if you have any common logarithm without base, the base should be assumed to be, you assume the base to be 1. Then let me bring all the concept with log to one side. That is, I will have solution. This is the question. I will say this is log x minus s plus 9. So if I bring this here, I can bring this here. It is initially we have it as negative. By the time it crosses this equality sign, then it changes to plus. I have log x minus 2. Then if I bring this, it will be minus log x plus 1, everything equal to 1. Then if I apply the law of the first and the second law of logarithm, I can rewrite this as log x plus 9 multiplied by x minus 2 all over x plus 1. That's what you have. Everything equal to 1. Then, since I decided to clean the base the other time, I can call the base 10. I will change it to base 10 so that at this point now, I can rewrite this from logarithmic form to index form. That is, this logarithm now will be equal to 10 raised to power 1. That is, I can say x plus 9 multiplying x minus 2 all over x plus 1 is equal to 10 raised to power 1. So it is allowed when we apply the law of logarithm, or how to convert a logarithm to index form. Then 10 raised to power 1 is 10. That is that. So I will cross multiply from here. I can cross multiply. And if I cross multiply, I will have x plus 9 into bracket x minus 2 to be equal to 10 multiplied by x plus 1. So we'll open up here. I'm going to have x squared minus 2x plus 9x minus 18 to be equal to 10x plus 10. So I want to bring everything to one side so that I will have x squared. That will be minus 7x minus 10x minus 18 minus 10 equal to 0. Then I can rearrange here so that I'm going to have x squared minus 17 minus 17x. No, is it minus? This one is initially, we have this to be 10 here. It is 10 here. On getting to this place, is minus. Okay, here is plus 7 because 9 minus 2 is 7. Then 7 minus 10, that will be minus 3x. This is minus 18 minus 10, that will be minus 28 equal to 0. So we have gotten our quadratic equations, and this quadratic equation can be simplified. Then we have minus 28. So I can express this as x squared minus 7 times 4 is 28 minus 7x plus 4x minus 28 equal to 0. So we do the grouping. X is common here. We have x minus 7. Then plus 4 is common here. We have x minus 7 equal to 0. So we have x minus 7 into bracket. We group these two together. X plus 4 equal to 0. So from there now, we say x minus 7 equals 0 or x plus 4 equals 0. Then, if that is what we have, then from here, we know that x is equal to 7 or x is equal to minus 4. Therefore, x is equal to 7 or minus 4. So if you look at the nature of this question, if you want to check and substitute back, the only one that satisfies the condition is when we choose x to be 7. That's what satisfies the question, the condition of the question that we are given. So with this, we have been able to solve logarithmic equations. So if you have further questions on logarithm and logarithmic equation, you can just write it at the comment section. So I promise to respond to all your questions. So I would love to stop here. And I'll be expecting your questions. Thank you for listening. I'm over show.